In the last video, we saw how to sketch the graph of the equation y is equal to x squared minus 4x plus 9, and it looked a little bit like this, where we had an upward facing parabola that had its vertex at the point 2, 5. 2, 5 is the vertex. We didn't have any roots because it started above the x-axis and went up infinitely. From here we went 1 and then 1 because 1 squared is 1, and we did that as a mirror on both sides. Then we went 2 and 4 because 2 squared is 4. We would have gone 3 and 9 if we were to go up this way, right? And that's how we find our points for the parabola. Notice that we have an axis of symmetry with a parabola. The left side looks exactly like the right side, so that's why I was able to know that if I went if I went out 1 and up 1, then I would also go to the right 1 and 1. If I went forward 2 and up 4, then I would go to the left 2 and then 4, because of that axis of symmetry. So what happens now when we invert? Let's do the inverse of this parabola. Now the way to do an inverse is to switch all x's and y's. So this says y is equal to x squared minus 4x plus 9. So the inverse then would be x is equal to y squared minus 4y plus 9. And we can graph it using the same principles we did in the last section. We used completing the square. So x would be equal to y squared minus 4y. I'm going to leave out here plus 9. And then we did plus 4 and then a minus 4 to balance out correctly. So then what we got was x is equal to the quantity of y minus 2 squared plus 5. And so how we would graph this one now would be to invert our x's and y's. So here we have 2, 5. So if I were to make this 0, that would have to be a positive 2 in the y direction. So I would go up 2 and over 1, 2, 3, 4, 5. And then we would have to again invert. I'd have to go up 1 and over 1, down 1 and over 1, up 2 and over 1, 2, 3, 4, all from the vertex 1, 2, 1, 2, 3, 4, or go up 1, 2, 3, and then go out 1, 2, 3, 4, 6, 7, 8, 9, 4, 5, 6, 7, 8, and 9. And then my graph would look something along these lines here. I could round that off a little better, couldn't I? Something along those lines there. Now, this is an inverse. And what I want you to understand about the inverse is that this also has an axis of symmetry, right? Our axis of symmetry for the inverse is that y is equal to 1, 2. Y is equal to 2. So with our normal open upwards parabola, our axis of symmetry is x is equals, where with our inverse parabola, which is not a function, right, because it doesn't pass the vertical line test. Oh, look, it passes through 2 points. This is not a function. Our axis of symmetry is y equals. And the beauty part about your inverse functions is that they always follow this rule. I have this y is equal to x line here. This is not the best line, but that's my y is equal to x line. And notice that if I were to fold this graph along that y is equal to x, then my parabolas would line up. So that's just a little bit about inverses of parabolas. They are sideways facing parabolas along an inverse axis that is y is equal to x.